Start.
Hello students, today I am start plus 2 physics unit number 1 electrostatics. Electrostatics which include 5 subchapters which are Coulomb's law, electric field, Gauss theorem, electric potential and capacitance. This unit contain 8 marks in the CBSE exam. First of all, we start first chapter Coulomb's law. In Coulomb's law, the first topic is charge. First question is what is charge? Charge is the additional property of an electron which give rise to force between them is called charge. Basically, charge is of two types: positive charge, negative charge. Positive charge is on proton and negative charge is on electron. In electron and proton, the amount of charge which is denoted by small e is equal to 1.6 into 10 the power minus 19 coulomb, and mass of electron is 9.1 into 10 the power minus 31 kg. Similar mass of proton is 1.67 into 10 the power minus 27 kg. After this, we have some properties of charge. First property is like charges repel each other and unlike charges attract each other. This means positive charge repels another positive charge, but a positive charge can attract another negative charge. Second property is quantization of charge. This means all observable charges in the universe are always integral multiple of smallest amount of charge. In this, Q is called total charge, N is integer which has the value of 0, plus minus 1, plus minus 2, plus minus 3. E is the elementary charge which has value of 1.6 into 10 the power minus 19 coulomb. Third property is conservation of charge. Conservation of charge is charge can neither be created nor destroyed. It can be transferred from one body to another. For example, when we rub two bodies, then one body lose electron and the other gain electrons. It is called conservation of charge. That is, the total charge always remains constant, conserved. Next one is additive nature of charge. This means that the algebraic sum of all the charges distributed on the different parts of the body is equal to the total charge. Last one is charge by induction. This means that if we have an charged body and another uncharged body, when we place another uncharged body near charged body, then charge is taken on the uncharged body due to induction. These are the 5 main properties of a charge. In this, we have some questions. The first one is how does the mass of body be affected on charging. That is, when we charge a body, the number of electrons are added or removed. This means when an electron is added to a body or when an electron is removed from a body, the mass always increases or decreases, because a mass of electron is always remains constant. It has value 9.1 10 the power minus 31 kg. Mass increases when electrons are added to a body and mass decreases when electrons are removed from a body, because electrons are a elementary particle of mass 9.1 into 10 the power minus 31 kg. The second one is how many electrons are given to a charge of 1 coulomb. Answer is Q is equal to Ne. Q is 1 coulomb, E is elementary charge 1.6 into 10 the power minus 19 coulomb. Then Q is 1, N into 1.6 10 the power minus 19 coulomb. Then N is 1 over 1.6 10 the power minus 19, which is 0.625 into 10 the power 19. Number of electron has no unit. The next topic is Coulomb's law. Coulomb's law, if we take two charges Q1, Q2 are placed at a distance r apart, then the force of attraction or repulsion, which depends on the nature of the charges, is directly proportional to the product of the charges. That is, F is directly proportional to Q1, Q2 and inversely proportional to the square of the distance. That is, F is inversely proportional to 1 by r square. When we compare these two equations, we find that F is proportional to Q1, Q2 over r square. In this, the constant of proportionality is K. K has value 1 by 4 pi epsilon naught. This is called epsilon naught. The value of full this constant is 9 into 10 the power 9 Newton meter square per coulomb square. That is, F is equal to 1 by 4 pi epsilon naught Q1 Q2 over r square. Epsilon naught has value of 8.854 into 10 the power minus 12 per Newton per meter square coulomb square. That is Coulomb law is, it states that the force of attraction between two like or unlike charges, force of attraction or repulsion between two like or unlike charges is directly proportional to the product of the charges and inversely proportional to the square of the distance. After this, dimensions of K. For this, in this formula, we find out the value of K. That is, K is F into r square by Q1 Q2. Force has the dimensions m1 l1 t minus 2. R is the distance, it has dimensions of l square. Q1 is I into t and Q2 is I into t. That is m1 l3 t minus 4 and I minus 2. It is the dimensional formula of constant K. After this, define 1 coulomb. For defining 1 coulomb, we take Coulomb's law. In this formula, force is 9 into 10 the power 9 Newton. We take Q1, Q2 is equal to Q. R is 1 meter. Put value in this formula. So we get Q square is equal to 1. That is, Q is equal to plus minus 1. If we take Q is equal to 1, then value of Q1, Q2 is 1. And if we take Q is minus 1, then value of Q1, Q2 is minus 1. That is, these two charges are of similar type. That is, either positive or either negative. This means 1 coulomb is that charge which repel another similar and equal charge with a force of 9 into 10 the power 9 Newton when placed in vacuum at a distance of 1 meter apart. This is the definition of Coulomb. Is like state and explain Coulomb's law in electrostatics using this law to define the unit of charge. The next topic is dielectric constant. Dielectric constant. Dielectric constant is denoted by either K or epsilon r. Epsilon r, which is equal to force in vacuum over force in medium. Force in vacuum over force in medium. Definition is simple. Dielectric constant may be defined as the ratio of the force in vacuum to the force in medium. Force in vacuum is 1 by 4 pi epsilon naught Q1 Q2 by r square, and in medium the force is 1 by 4 pi epsilon Q1 Q2 by r the square. Then value is 1 by 4 pi epsilon naught Q1 Q2 by r the square over 1 by 4 pi epsilon naught epsilon Q1 Q2 by r the whole square. Cutting this cut, this cut. then K is epsilon by epsilon naught, that is epsilon is K into epsilon naught. If we take force in medium is 1 by 4 pi epsilon Q1 Q2 by R the square, then value of epsilon is K into epsilon naught into Q1 Q2 by R square, then 1 by K 1 over 4 pi epsilon naught Q1 Q2 by R square, that is F medium is 1 by K F vacuum. This means that if we take the charges in another medium, then the force between them is reduced 1 by K times, that is K times. For example, if we take two charges in water, then the electric constant of water is 80. The force in water is 1 by 80th time the force in vacuum. This is called dielectric constant. Dielectric constant has no unit because it is the ratio of two same quantities force, that is Newton by Newton. It has no unit, it has no dimensional formula.